All right, is everybody ready to get started? And for our online audience, can everyone hear the interpreters? If you can or cannot, please let us know in the chat. All right, it seems like from the chat, everything's good. Thank you again, everyone, for joining our VL2 Discovery Blitz. And in addition to our online audience, we also have a good number of folks here face-to-face. We are very excited to celebrate the discoveries that we've made this past year. In our Discovery Blitz talks, we have an important emphasis on the discoveries that we make that impact society. I am very excited to share our recent findings. If you could go to the next slide. Oh, I also forgot to introduce myself. Hello, everyone. I'm Dr. Rachel Pizzi, and I'm a professor here at Gallaudet University in the Visual Language Visual Learning Research Center, and also a professor in the PhD of Educational Neuroscience, or PEN program. So first, let me explain what a lightning talk is. This is a learning experience to be able to communicate our scientific ideas clearly as well as succinctly. Within each lab, each person has been given 3 minutes to give a presentation. Individual presentations are 3 minutes, group presentations are 6 minutes. And we will give everyone a little grace period of 15 seconds. But the time limit is very strict. So if a presenter goes over time, they will get caught by the bison. Who is here? So again, if the presenter goes over time, they will get caught by the bison, and this slide will come up to indicate that they are over time. We will get started, and of course, I'm going to kick off our talk as our first presenter. Oh, and we've got, and somebody's asking to spotlight you on the laptop. Yeah, you are already.
Just a clarification from the audience that it seems as though our virtual attendees can't see.
All right. Thank you for our in-house team letting me know. Can everyone see?
All right, your time starts now.
Thank you, everyone. Next slide. In my lab, we're looking at how to measure anxiety in deaf and hard of hearing people, especially academic anxiety. Next slide. Academic anxieties in this context are negative feelings or stressors related to specific academic topics like mathematics, writing, etc. And these academic anxieties not only feel bad, they're also associated with poor performance. And within the deaf and hard of hearing community, we know less about deaf and hard of hearing students' experiences with academic anxiety. Research from my lab demonstrates science anxiety, math anxiety, and is negatively associated with STEM outcomes in deaf and hard of hearing participants. Next slide. We'd like to understand more about academic anxiety, especially within the deaf and hard of hearing community, and therefore we need a tool to be able to measure that. In this study, we used the Academic Anxiety Inventory. This was a previously developed questionnaire with 50 items. And those items are across specific domains: math, science, writing, testing, and trait anxiety. ASL translations of each item are aligned with written English questions. We wanted to find out if this questionnaire was reliable and valid. We did this using an online study, collecting a plethora of data. We had 145 participants. Next slide. First of all, we wanted to know if this is a reliable measure, and we found is yes, it is. We used a statistic calculation of reliability, and we found that all of the 5 domains were above the reliability criteria that we had set. So now we're looking at each individual item and how it relates to the subscale for each domain. So if you go to the next slide. Each line on the wheel represents a single question, and we wanted to know how close to the outside those numbers were. So each question, we wanted to look at how that individual question related to that domain. So you can see that if the color writing is related to the domain writing, oh no, I got caught by the bison. Oh well. I think we have time for one question. Next slide. Because I got caught by the bison, so we need to go to the next slide. Bison caught me. Anyway, I got caught. Any questions from anyone? All right. We also have time for question and answers at the end of the entire presentation, and we will open it up for time for questions from the audience. And if you have questions from our online audience, if you would type them in the Q&A feature, that would help us a lot. Our next presenter is Christina Kim. Christina, you're up.
Interesting start for the day. All right, am I good to go? Just let me know when to start.
Ready? Go.
All right, hello everybody. My name is Christina, and I'm going to be presenting on how we can measure language anxiety. So what does language anxiety mean? They're the negative emotions that are expressed, that are part of our expressive or receptive language skills. For hearing people, we've understood that
Language anxiety.
Language anxiety impacts behaviors, social emotional health, and proficiency. And the impact of anxiety and depression, feelings of loneliness, and the impact of improving language knowledge and interacting with others, people will tend to avoid them, and so they'll miss out on opportunities to improve their skills. So we've looked at that population of hearing people, but what about deaf and hard of hearing and deaf-blind individuals as well? What does that look like? What does language anxiety look like within our community? We wanted to know what these patterns looked like, and in order to capture that, we've created a survey which we're calling the LAI, the Language Anxiety Inventory. It was a long process. There required a lot of collaboration with deaf, deaf-blind, and hard of hearing people, advisors, sitting down with various stakeholders and asking them questions about their childhood and their experiences growing up. And through an iterative process, we've developed this tool in both English and American Sign Language. The structure of the LAI is that it's in both languages, English and ASL, asking questions about early childhood, current experiences within the last 3 years, receptive skills, and expressive skills. And then in addition, for the English section, there's also a reading and writing component. Next slide, please. Here are a few examples of the various items that we've developed. These are reported on a scale of 1 to 5, from no anxiety to significant anxiety. And then there's also an option for does not apply. If someone became deaf later on in life, then that particular question may not apply to them. Next slide, please. We are now recruiting for validity and reliability testing, so please share this information with your friends and colleagues. Next slide, please. A big thank you to the entire team. It's been a team effort getting this going.
She didn't get caught. Hello, everyone. I'm Rachel the Third from Can Lab. Ready to go? Surprise, I also study academic anxiety, and I'm focusing specifically on STEM learning. Next slide. In my study, we measure learning in two different ways. We measure anxiety in two different ways. First is the academic anxiety inventory that Rachel talked about in her talk, and the next is electrodermal activity, which measures levels of sweat, basically measuring sympathetic nervous system activation. That tells us if a person is engaged or anxious. And we measure on the foot. That way, because if we were measuring on the hands, participants would not be able to use their natural language of sign language, and so instead we measure based on sweat in the foot. In order to measure learning, we have participants take a pretest, then watch 4 different videos around science and mathematical topics, and then they'll have a moment to summarize what they learned in ASL. We also collect EDA data while they watch, as well as while they are taking this cognitive matching task. They have to decide whether these two concepts match, and then afterwards they take a post-test, and we can see if their scores improve from the pretest. Our first general result is our participants did learn. We developed lessons and we tested them ourselves. They were all new, and so we weren't sure that participants would learn, but they did, and that's great to know. Next slide. And if people had more anxiety, they learned less. Their scores were generally less if they had higher math or science anxiety. And so we can feel assured that we are specifically measuring something related to math or science. So we're correlating that with their performance. Now, the EDA measurements had no there's no score related to their physical.
It had no relation.
It had no relation to that score of their physical anxiety. Their self-reported anxiety was related to their learning, but not to their physical experience of anxiety. So that measure can mean a person's either anxious or engaged, so it's not a perfect predictor of performance. And thanks to the team that worked on this project.
Another one not caught by the bison. Hi there, everybody. My name is Katie. I'm an undergraduate research assistant for the lab, and I'll be talking about my honors capstone project, which I've been doing for the last year, looking at the relationship between stress and disability. The reason why I'm doing this research and why it's so important is that there's not a lot of research on people with disabilities, but people with disabilities experience nearly 5 times more stress than able-bodied people. Next slide, please. My study was 100% virtual, and it was taken via Qualtrics, responding to demographic information for the survey, plus it asked their disability diagnosis, how long they've been diagnosed, and then also 2 metrics that you see here on the slide, which were important because we have the HUDAS from the World Health Organization Disability Assessment Scale, and then what does the impact of their disability on their daily life look like, which is captured via the DRSS, the Disability-Related Stress Scale. And then we can compare to see the severity of their disability and if that relates to the amount of stress that they report. And what we found is we had a total of 31 participants, mostly white females from Gallaudet University. And one thing that we noticed is that 26 of them were deaf as their disability, which may skew the data a little bit as compared to other disabilities. There were also some secondary disabilities reported, for example, mental health disabilities and learning disabilities. Here is our data. We can see that there is a correlation that the severity of the disability and their reported amounts of stress, and we have data to prove that result, a positive relationship. The general result says that when the disability impact increases, we see an increase in stress as well. And we need more research, and hopefully I will get that research during my graduate school experiences. And thank you, everyone.
Good job, and you didn't get caught. We also have a request to add captioning. And so we are going to turn captioning on now.
I think the captioning has been turned on, but let me know if it's not working.
Can our online participants let us know if if you can see the captioning? Yes. All right, our next presenter is Rachel Ingram. My project was how do deaf individuals feel about mental health words? Why this is important is we know that when deaf individuals try to access different forms of healthcare, often they face a variety of different barriers. And we also now know how people feel about different topics related to motivation, interest, learning about those topics. So knowing about this may create different and additional barriers depending on a person's perspective. Next slide. We showed participants 120 words, 60 related to mental health, and 60 were non-mental health words. 20 in each category were positive, 20 neutral, and 20 negative words. There were 2 questions for each word. One was, how positive do you feel about this word? And the second was, how negative do you feel about this word? We predicted that people would rate mental health words more negatively when we asked them how negative they felt about those words. And that didn't happen. We did not see a difference between mental health words and non-mental health words when we asked specifically how negatively they felt toward the words. But, next slide. When we asked how positive they felt about certain words, surprisingly, we saw the mental health words were related more positive than the non-mental health words. What that means is that within this population that we surveyed, they had positive perceptions about mental health and possibly better access to mental health services. And that's it. So an additional Rachel was not caught by the bison. So 1 out of 3, no, 2/3 of the Rachels were not caught by the bison. So maybe I have math anxiety because I can't count. We have 1 question from our audience member. This question is for Christine Kim. So I'll turn it over to Christina to answer the question.
Yeah, thank you for that question. For this research study, we are currently recruiting specifically from adult populations. And we want to sit down with them, have an interview to talk about their experiences in childhood. And so we're looking for adults, which may not be a good selection from teenagers, but we're hoping that this newly developed metric for adults will help us to think about how we can adapt things like this for children, adolescents, and teens. Our age range right now is from the ages of 18 to 60, people who are deaf, blind, and hard of hearing. So we're looking for adults. And we are recruiting nationwide, and our goal is to get over 200 participants. So we're pushing really hard for this round of recruiting. And we require basic proficiency in ASL and English. Some adults have just started to learn a little bit of American Sign Language. They maybe have grown up using spoken English, and they are welcome to join our study as well. There are some who have come to America later in life and are still learning English. They're also still welcome to take part. We want to capture a diverse range of experiences. And we're not necessarily looking for those who are native or fluent signers or native or fluent speakers of English. We're looking for that mix. So thank you for that question. I'll send out the recruitment information that hopefully can be shared with everybody as well. All right, can everybody see me okay? Hello, I'm Dr. Ilaria Bertoletti, and I'm going to be presenting with...
Hi, everyone. I'm Bridget.
Make sure you are on camera.
Again, my name is Bridget, and I'm the lab manager for the NENS lab.
Wonderful. Next slide, please. So transitioning into our topic. Our team is a very large team, and I want to make sure that I want to recognize everybody who's contributed to this project. Without them, none of this could have occurred. So thank you so much to our team. Next slide, please. Our project is researching how language modality and experience have an impact on early numeracy, number concept acquisition. We're looking at early math, early numeracy as a predictor of later academic success, and also how to support children. And then we're also publishing research.
All research that has been done.
All research has been done on this area has been about hearing people who don't know sign language, and so we would like to get some more information on how ASL influences that process.
Give everybody a few seconds to read the slide.
Longitudinal.
This is a longitudinal study. We're collecting data 3 times every 6 months, studying children and assessing their numeracy skills. We're looking at how children learn quantities, numbers, counting. So for example, we might ask a child to give us 3 strawberries, and then we will score based on the number of strawberries that the child gives the researcher. And right, we're studying children ages 3 to 5 years old. There's also 3 groups: early signers, late signers or late sign exposed, and hearing students.
Wonderful. Next slide. Here are the results. You can see here from the time 1 on the left and 6 months later on the right. You can see that the children's performance and how many accurate responses they've given goes up. Looking at young children from 3 to 4, they start to show a minimum understanding of counting very low, and then they improve 6 months later at an incredible amount. And that tells us that how children acquire numeracy is not consistent, but it happens in stages. Next slide, please. This graph shows that same exact data, but gives you a different perspective on it. Across the x-axis is now the highest number that the child knows and gets correctly, and then how many children is shown on the y-axis, how many achieve that stage. And so you can see that we have some children who have a minimum understanding or no understanding, then they have a basic understanding, and then they hit some type of cognitive ceiling. Oh, all right, that's the first time it's happened for me, that's all right. I'll go ahead and end here. Since we run out of time and they're not allowed to finish their part of the presentation, question from the audience.
So we've had a request what was the end, or what was, I guess, just can you summarize what were the findings about the numbers that children knew? So
from the audience, yeah, just a general summarization so the audience gets an understanding. We saw that children's acquisition was not necessarily linear, but happens in stages. And when we compare that pattern with hearing children, we see that ASL, the exposure to American Sign Language, may have an impact if you have early exposure to American Sign Language on those stages. I forgot to mention here that early exposure to sign language does have a positive impact on their numeracy acquisition, but we don't necessarily know if this pattern is going to look exactly the same as hearing children or not. If there's a difference, that means that there may be some specific characteristics to ASL that impacts their learning for numeracy. Thank you for that question from the audience.
All right, I'm ready. Hello, everyone. I'm Casey Spellman. And if you'd go to the next slide. I'm going to discuss some of my early dissertation results, specifically looking at the brain areas that support subtraction solving, based on that the brain area doesn't care if you sign or speak. My study was done using fMRI. And there were two research questions. One is, how do people learn math through ASL? And the second is visual spatial skills. How do those influence the brain's activation during the process of subtraction? One of my tasks was, first I wanted to identify where in the brain that supports number and quantitative processing. People will see the dots and numbers and respond if they match, and we looked at brain activation during that task. From there, we identified two areas, one in the right and one in the left hemisphere, that support quantity processing. We found those in the left and right interparietal sulci. And then within that region of interest, we looked at where activation is specifically for subtraction processes in hearing non-signers and deaf signers. Participants will see both subtraction and multiplication in the scanner, and we are looking specifically at activation during subtraction problems. We see the hearing non-signers in blue and the deaf signers activation in green. Activation is very similar. We saw no significant statistical difference. Then I wanted to know about their visual spatial skills and how that impacted activation. This task, they would see dots show up in a graph, and if they saw a dot, they would have to decide if that dot matched a previous location of a dot that they saw before. We then ran a correlation with activation during subtraction, and we didn't see any correlation between visual skills and subtraction, but it's within the ROI. So the next step is to look at the whole brain to see if there's any correlation there. And that's it. Thank you, everyone.
Another one, not caught by the bison. Hi there, everyone. My name is Elizabeth. Again, my name is Elizabeth Druby. So my topic is talking about synesthesia and numeracy in deaf and hard of hearing and sign language users. So synesthesia, I'll start by explaining what that is. It's one area of the brain being activated and triggering another. In some of the less common examples in sign language where you maybe would see a sign and then you'd have colors, for example, like pink streaming out of it. So we have two hypotheses, two research questions. The first one is, what is the percentage, the proportion in the deaf and hard of hearing population? And neuroplasticity. And then also the impact of language, looking at deaf signers,
One study with two.
one study with 2 hearing signers, L2 signers.
So I went into classrooms, there was 92 people who took it. And so looking at the classrooms, again, here N equaled 82. We're looking at percentage and outcomes. Estimated a 33.26 prevalence. And then for the second phase of the study, we asked the person to take the questionnaire 2 times over 2 weeks. We had 2 groups. One is synesthesia, the other is non-synesthesia. In the synesthesia group, we didn't ask them to memorize. We asked people in the non-synesthesia group to memorize for the second questionnaire for 2 weeks later. And we've got the 2 participants in the synesthesia group, but 1 participant, we had 7 people in the non-synesthesia control group. So we were looking at the sign, specifically for the letter, and the color that they saw. And what we saw from all of the data possibly means that it has, there's more impact, the manifestation of sign language than the manifestation based on phonology.
All right, congratulations, another one not caught. Okay, to do this one.
All right, hello everyone. I'm Dr. Lorna Quant, a faculty member here at Gallaudet. Next slide. And today I'll be discussing augmented reality and ASL, how we are connecting those two and why. What is augmented reality? Basically, you put on goggles like you see here, and a person can see the real world, the real space that they're in, but we can overlay other things on top of what you're seeing in the real world. This is my office. And I've added a piano. I can learn to practice piano in my office. There's no real piano there, but we overlaid that, a fake piano in my office using the goggles. This is another example. We can imagine, and I see a lot of potential here for this technology to be applicable for deaf and hard of hearing students. How that might work is that we can imagine a deaf or hard of student putting on these goggles and they see the real world and the real space around them. And maybe a model or other graphics will come up. And if you want to make it more accessible, you could also add captions. If you would click on the video, hurry up, then you see the structure. And then if you want also, you can add other things like a signing avatar. That way this person could explain what a person is seeing in a different modality. If you wanted, you could even add a third modality. Haptics. That way a person, would feel like they're playing a video game. And then you could combine them all. But sometimes that's overwhelming. Maybe a person doesn't want to have all of these different modalities shared with them at the same time. It might be too much. We have a new grant to be able to explore this question with deaf and hard of hearing students. The grant will enable us to do 3 things. Our first goal is to understand how this type of multimodal learning can function well and not be overwhelming for students. The second is we want to learn how deaf and hard of hearing students experience the technology, what they like and what they don't like. The third is to develop and test new experiences in AR, combining these multiple modalities to produce a better experience for deaf and hard of hearing students. Right now, we're running focus groups. We're bringing together students to do a pre-test. We're basically asking them what their opinions and ideas are about augmented reality. And then the second group, we're providing augmented reality to them, let them try it, let us know what they liked and didn't like. And the third group is a discussion group where we just learn from them about their thoughts about augmented reality. And then next, thank you so much. This is probably the first year that I didn't get caught by the bison. Yay!
Dr. Quant, not caught by the bison. Congratulations. And our next two presenters are currently attending a conference. And so they've submitted some videos in their stead for their presentation. So they're automatically not going to be caught by the bison, they're safe. So the next up we have Melody Schwenk. Hello everybody, my presentation is about the neural mechanisms of spatial cognition in ASL users. I'll be looking at what are the influences of ASL on spatial skills and development is. There's a lot of research that's explored the influence of age of acquisition on spatial fluency in terms of signing, but we don't necessarily have a lot that focuses on two areas: fluency of ASL and also how the brain responds. We do have some evidence that supports a relationship there, but we don't necessarily have enough evidence to conclude that yes, fluency is one of the primary reasons for spatial skills development. I'll be taking a look at 3 different skills, but I'll be using mental rotation as a proxy for orientation skills. We'll be looking at mental rotation and how people visualize something that's not actually tangible or physically there, and then trying to mentally manipulate that in their mind. And also perspective-taking skills. Explain a little bit about that. How we can perceive things from another perspective. I'll be focusing on 2 types: egocentric, meaning body-centric, how we understand 2 things related to each other, and the other one is allocentric, which is based in landmarks and maps, which is how we typically define things to other people. So we're going to be recruiting 65 participants, deaf fluent signers, hearing fluent signers, deaf non-fluent signers, and non-fluent signing hearing people. And why we're including hearing non-signers in this is because it provides support for my task to see the influence of ASL, if it influences it or not, if it's just due to visual complexity. And this is an important study moving forward because it emphasizes how we can educate deaf children in science, mathematics, and how we can reinforce the use of visual information and leverage that native intuition and the understanding of visual spatial things that they have. All right, thank you everyone, I appreciate your attention today.
All right, our next speaker is also remote, and you will see their video presentation. Hello, everyone. My name is Joseph Palagano. I go by Joe. I'm a third-year student in the PhD in Educational Neuroscience program studying under Dr. Lorna Quant. And I did a project with the Play Lab talking about looking at sign language versus non-sign language exposed children's gaze patterns toward dynamic sign print storybooks. First, I want to give you a little bit of background about the storybook and voluntary perceptual gaze control. As children acquire language, they understand where to look to get environmental information. Digital media provides important language acquisition, exposure, and access for deaf children, but we currently haven't investigated how deaf children modulate their gaze when looking at digital media and the app itself, providing sign language avatars, captioning, moving backgrounds of pictures. We have two predictions: that language exposure and experience will impact visual attention, and the second prediction is that a better understanding of the story will align with longer gaze targeted in the facial areas and signing spaces. The goal of this research project is twofold. First, to help us better design and advance our storybook apps to become more attractive and entertaining for deaf children. It'll also help to possibly identify who is struggling with literacy and provide help in attenuating their visual gaze. The project is looking at children who are sign exposed or non-sign exposed. As hearing children watch the signing stories, we're looking at their eye gaze and then testing comprehension. We also look at sign exposed children who are fluent signers and their eye gaze and attention. There are 4 areas of interest: the signing space, the face, caption, and the background image. What we found is that sign exposed children increasingly do well on the comprehension assessment, but the non-sign exposed children, their performance is floored. What we also found is that children who are exposed to sign language at a young age are able to look at the face, whereas non-sign exposed children don't necessarily have a targeted gaze. They often look at the picture and the background, and we find that information interesting. Please feel free to contact me if you have any questions or want to know more about our research. Thank you to the team, the funders, VL2, and our old team who has developed these storybook apps at ML2, and of course the participants and parents who helped us with this to make this project possible. Thank you, everyone. All right, is everybody ready for our next face-to-face presenter? Megan, come on up.
Can everyone see me okay?
I think so.
All right. Next slide, please. My topic for today is how we might be able to use embodied cognition to help mentor and support people who are learning sign language. Next slide, please. So imagine a person wants to acquire ASL. Where do they start, right? Where do they start that process? Now suppose we want to have iconic signs, but what does iconicity mean? They're signs that look like what they mean. And sometimes that overlap between meaning and form can be useful. And when people are acquiring signs that are iconic, like for example, the sign hammer, it correlates to how a hammer is actually used. And that connection will be based in past experiences with using a hammer and will help them to acquire that sign. Next slide. So this is how we know if that's true. There's two things here. Behavior, if they're able to produce that and understand it more easily. And also the cognitive complexity of the text using EEG. We can take a look at the brainwaves and see how much processing is needed. And we can see if there's reduced processing, then it's probably easier for them to do. Next slide. So what's the plan? We want participants whose parents who are deaf and hard of hearing, who have deaf and hard of hearing children, who want to acquire American Sign Language but haven't yet. We'll train a group of signers with motion-related iconic signs to see if the production tasks will help them acquire and understand these signs. Next slide. So what is my theory? That people will be able to connect their past experience with using something, like moving in an iconic way, with the actual sign itself, with motorically iconic signs. So it's probably a good starting point for those who want to acquire American Sign Language and they don't know where to start. But we need to do our research first, so we'll see. Thank you.
Another one that didn't get caught by the bison. Our next presenter, come on up. Hi, everyone. I'm Deanna Dunlop. I'm going to introduce you to the Bridge Project. This is an NSF-funded collaboration with 2 other universities. Next slide. So first, what is grounding? We want to understand how 2 people can share the understanding of a concept. And it can be hard for deaf and hard of hearing people in STEM classrooms that have no grounding experience. They're learning, they might not understand one another. So the goal here is to develop technology-supported grounding to assist that shared understanding of STEM concepts. Next slide. This is what we envision technological support to look like. 2 people using AR for learning support and are discussing a specific concept. We would have a real-time signing support that will show up. That would look like both avatar, captions, and an image that will support grounding and a mutual understanding of the STEM concept. We recently completed our motion capture recordings. Oh. The purpose of that was for avatar creation. Our next steps are threefold: human-computer interaction study, assigned data collection, and then third, building AI models to support grounding through sign language recognition. That's it. Thank you.
Congratulations, another one got away from the Bison. All right, hello everybody. My name's Taylor, the project manager at the Motion Light Lab, which we call ML2. Really excited to be here. We ready for me to start? Great. So Joe talked previously about the Storybook app, and that is an ML2 creation. Thank you for the reminder to stand here. The Storybook app includes both ASL and English, a video and sign language, and then also the book text in English. There has been some new updates recently, adding more features that I'd like to talk about. We're now collaborating with REAL, R-E-A-L, the Clare Center, as a grant, and we're working with them to create their own storybook. Let me give you a little bit of history. The Storybook app is used to teach people, and we're also teaching people how to make their own storybooks as well, and the Clare Center is in that process. There are some things, like for example on iPhones, people have been reaching out for the ML2 Storybook to be available on iPhones, and it hasn't been because funding is limited, and we couldn't make that happen. But with this now, we're able to make that happen via new updates. Next slide. This is a big deal for us. ML2 apps, we had the Storybook app, and if you want another story, you have to download a second app, and it becomes a little bit cumbersome. We've made over 100 of them now. There are 40 different stories in total, and downloading app for each of them is not necessarily fair to families. So we're housing them now all inside one app, which is a huge deal. So inside that app, which if I can pull out my phone here and show you, maybe it's a little bit hard to see, but here are all of the different stories now inside one app. And what's great about it is it's completely free. Many families are going to benefit from using this free product. And then the design for them is very similar, so you can hop in and out of these stories and continue to read. This is available now finally on iPhone. And so everything's incorporated in one app, available on iPhone. Those are two of the brand new updates. The Clare Center also has over 40 different free books that are being used from like library books, Todd Parr, famous author, and some of these original ASL stories that have no English counterparts already. But we're now making them available, adding in new features. There'll be a subscription model that more information will be made available. In the past, there are a lot of things that we couldn't do. We're giving things away for free, but now some of these advanced features will be on a subscription service. So those are some of the new updates. Moving forward, what is our plan? We want to make sure that deaf-blind children also have access to these. And so we're working on additional features that will have a black overlay so that you can also change the size of the English text on the screen and the colors and adjust the contrast as well. We also want more accessibility for everybody. So that's one of our priorities. Next slide, you can go ahead and play the video. You can download the app for free. This is for 0 to 3, ages 0 to 3. All right, I'll take it.
Thank you, Taylor. Really cool to know the new updates for bilingual storybooks. I just said. What?
So the bilingual
Bookshelf.
bookshelf is on the App Store, and then the other one, this one we just saw, is called Little Colors for 0 to 1, for little ones. Is that the only question we had for me?
Download this.
So our last presentation for today is a group presentation.
We get more time, woohoo!
We have the Motion Light Lab, ML2. So thank you so much, Dr. Malskun.
And Rachel. Before we get started, I just wanted to make a comment that the video that you just saw, we're adding specific information for parents to be able to understand the signs and how deaf children see and conceptualize this. It's very powerful. We got some very powerful positive feedback on that. So it's just something that you didn't get to see in the last presentation. Should we start?
Make sure I'm in frame too. Can you see me?
Hello, everyone. My name is Melissa Malskun. I am the founding director of Motion Light Lab and presenting this with my colleague.
Hi there, I'm Jason Lamberton, the Human Computing Interactive Coordinator for the Motion Light Lab. I do the motion capture for ML2.
We want to focus specifically on 3D signing avatars and how we define and elevate the standards worldwide. We know that AI and translation is exciting, but who says what is okay and what is acceptable for deaf children? We don't want them to suffer with low standards. We want to make sure that they have the highest standards in ASL technology. You don't have to read this slide. We have several important projects that help to maintain elevated quality for deaf children. We're working with the Canadian Cultural Society for Deaf Children. They have a wonderful grant project. They funded us from Canada. It's a broadcasting company, and that funding has gone toward understanding what the standards are and what is the process for creating 3D sign language avatars and animation for television. They contacted us because of our reputation and asked for a partner to help develop avatars for their research studies, which is right now being conducted. They have already been working with their motion capture, and then we animated a signing avatar. That means that we did not conduct the motion capture here. We typically do have that pipeline, and we do everything in-house from the motion capture to the animation. But this time, they had already done the motion capture, and then we had to embed that in our pipeline. And that's something that Jason and I will try to elaborate on in the 6 minutes that we're given. Next slide. We are specifically looking at impact and how this work will impact society. The experience with Canada and the other work that we're doing here, developing the character of Mavo, will release the first ever television episode for deaf children with signing avatars this fall. And that has helped us to understand the people that we need on the team to help build capacity for this work. We need people who will do the scripting and the storyboarding all the way to the television show, which is a fully animated in 3D. And we need to understand the pipeline of that entire project. No question, we are leading in the industry in standard and expectations, specifically in the area of sign language avatars. There are a lot of people that are doing this work, but we want to elevate it to the type of work that we are doing now. And we know that the technology is only going to grow and expand from here. One exciting thing is that we are investigating how AI can fit in this process. Now, of course, we always want to be human-centric with a human-centric design, but AI can help speed up the process. That doesn't mean that we'll depend fully on AI because we know that it currently has a lot of errors, but we just want to help use AI to help our work be faster, get more sign language accessible resources to the community more quickly. Jason?
Yeah, if we can go ahead and show the video, please. Notice here, both of the hands. So our pipeline, in the other presentation you saw what our studio looked like. We have a performer who's in a full mocap suit with cameras surrounding them. This is from the Canadian project. They had their own motion capture equipment and their own setup with sensors on the body, and that data that we received from them was very different from what we're using in-house. And so we had to figure out a way in order to make it look acceptable for the purposes that we've set. So next slide, please. Go ahead, next one too. So as you can see, the hands have been manually corrected in order to fix them. Took a lot of time. And our equipment, doing this is a lot quicker, but with the equipment that they had, that's maybe one of the uses of AI that we could foresee in the future is speeding up this process of cleaning up the animation. Next slide, please. This is what our process usually looks like. The cost of the equipment is probably prohibitive. In their studio, they use different types of equipment, which maybe isn't quite as expensive. We use top-of-the-line, state-of-the-art equipment here.
Same as Hollywood.
Same as Hollywood uses. And their system probably wouldn't be able to do sign language to capture the intricacies of all of the actions of the individual fingers, which we need to capture in our work. We've elevated the technology because we need these specific fine motor movements to be captured by the technology. If we can go ahead and play the video, please. Well, looks like our time is out. Thank you, everybody. Appreciate the team. Thanks to our team. We have a wonderful team over at ML2.
Yeah, I think that they would be real curious to see. It's really short, only about a minute. So I want to see a new preview, a question from the audience that means we can keep showing it. I just want you to get a preview of what that looks like. This is the Canadian project and the concept of what they're looking to design. I'd like to add to what Jason already said. What's interesting is that the pipeline that we have, now we're bringing the digital mocap data from Canada, and we've been working with hearing studios, but our team has realized that they're working from hearing eyes, they're not deaf eyes, and our understanding of culture and language is so rich. It's something that we live and breathe every day and is embedded in our process. So we can clearly see the difference. And what they're lacking, we have. It's been a great experience for us to work with them. And it's important because all of the results now will be documented and we'll produce a report about the process. And our goal is to release that report so that people who are, our goal is to develop signing avatars, know that they cannot do it without the involvement of deaf individuals. So that any sign language avatar is produced with deaf eyes on it at all times. So this has been a great process to be able to produce that type of report. And just a little preview of the Mavo TV episodes that will be released in the fall. This is a very early rough clip. If you're curious, that's a good sign. We've got one last video on the next slide, Rachel. I think that one is a very cool summary of our work. And we'll be submitting this for a grant soon. Thank you, everyone.
Thanks.
We're hoping to win the grant. And thank you, except that we've been caught. The floor is yours, Rachel. Did you want to check the chat?
Let's see, we may have some, let's check the chat.
Rachel, you need to move when you're signing. You're not in the camera.
I think our slide deck is actually stuck at the moment. Taking a look to see if we have any questions in the chat. So we had some questions about the technology. If it's available on
Is that related to
iPad,
Tayla's
phone.
presentation? I think that's related to Tayla.
Yeah, I think you're right. I think that goes back to Taylor's presentation. So which types of devices is it available on?
Yeah, the Storybook apps are available on all iPads, Android phone, tablets, mobile devices, not laptops yet. You can either download them on the Apple
Play.
Store or Google Play. Bilingual Storybook apps are now available on your phone. We are now in the process of an update and transferring all of the current ML2 storybooks to the phone. And so thank you so much for your questions.
All right, thank you so much to the ML2 team. All right, we have arrived here at the end. Everyone has given their presentations. And so we have time for questions for any of our presenters. So we'll open up to questions from the audience and any of our virtual attendees as well. Yeah, question, come on up.
So just wondering about the presenter who talked about mental health terms. I'm wondering, were you able to collect some demographic information? And if you were able to find some correlation between those who had a positive correlation and the demographic information?
So yes, we did gather demographic information, but we didn't find any significant correlation, no. But I would say that the cohort was highly educated, so we did think of that part.
Thank you. And if I remember correctly, the average level of education was a master's degree, right? So this was a highly educated group. It's nice to see a positive correlation and a positive view of mental health and mental health terminology. Let's see. I think that we do have somebody. Yeah, one person from Europe.
So Lorna is coordinating the computers and the slide deck for today, but do you mind?
Hi, can you hear me?
Yeah.
No. Hi, can anyone hear me?
Waiting to see the question. We're excited.
You can't hear me.
Okay. We do see a comment here in the chat. Thank you so much for hosting this and making it available for everyone. Joining from Europe. Top Friday night entertainment. It's inspiring because research presented in sign language is so rare and so empowering as well. Thank you. Thank you so much for that comment. Appreciate it so much. Oh.
Can everyone see me okay?
Hold on 1 second, 1 second. All right, thank you. Go ahead for your question.
I have two questions. First, thank you so much for all of the presentations. I really appreciate it. The first was for one presentation about language anxiety and the language anxiety questionnaire. I was wondering if that survey, what was the total number of people that they surveyed for language anxiety?
1 second. Christina coming back to the front. Hi there. Can everyone see me okay? Thank you for that question. So we had several rounds. In the first round, in the qualitative interviews, we had a total of 11, roughly 1 hour, 12.
12 people.
12 one-hour interviews with deaf, blind, and hard of hearing individuals talking about the range of experience, not only negative experiences, but positive as well, to take a look and see what type of patterns we could find from them. In the second, we had how many?
Yeah, these are cognitive interviews.
The cognitive interview, developing possible questions that related to the findings from those patterns in the first cohort. Feelings of being lonely or isolated, being left out in childhood, if they were mainstreamed or in a cluster program. Trying to develop possible questions that could be brought back to the cohort and then see if what the reactions were to that. If they liked this or didn't like that, different questions that weren't clear, or if there was another way to sign them. So we had 12 people interviewed in the first round, and then another 22 interviewed in the second. And then in the third, we had our pilot. We developed a survey, and then we asked people, what was your experience like? Give us comments on each of these things. And there were 20 people in that. And then also, from that third group of roughly 20 to 22 people who had taken our potential questions, we then asked an additional focus group to have some discussions about would they prefer it a one-on-one or have a group discussion. And so we had a lot of iterations and different groups, and we were lucky to collaborate with deaf people on our team who were researchers who ran that interview and advisors to find the best structure and different ideas that we could test out to try to be open to everyone's feedback. But great question. Do you need any more clarification or?
No, that was great. Very clear. Thank you. And then now with all of that information, do you plan to then, gather more information and then send out the survey and collect data again?
So after all of those numerous iterations with different feedback, we are going to be sharing the final survey. We are recruiting, so if you email me, or I think Dr. Quant put the email address in chat, or you can contact VL2@gallaudet.edu, I believe, or you can email me directly, our team, which is can.lab, so can.lab@gallaudet.edu. Either way you can get in touch with us, and we can send you more information about the survey. But we have the final survey. We're gathering people and their answers, and it feels great. We have a new way of measuring language and test anxiety, because from our discussions with people would always say that they experience anxiety with written English, and also when expressing themselves in ASL. And we have anecdotal experiences from people's stories. And now we have something that we can actually say, all right, we can have something here, and we can now develop interventions to improve or to reduce anxieties. And people become more invested and more motivated to continue learning.
Wow, beautiful. I will definitely reach out to you. Thank you so much.
Yes, thank you. All right. As the lab director, we're recruiting a lot of people, getting a lot of data, and so thank you so much for that question. Any further questions from our online audience or anyone here in the room face-to-face?
Looks like no further questions from the audience.
All right, next slide, please. We do have another question from our audience here in the room.
A question for Casey. I have a question for Casey. Your presentation was so fascinating about neural activation. And you showed one slide about activation that showed some blue and green, but I just was curious what the activation meant, if you could share more with the audience. And hopefully they are also curious. Do you want us to go back to your slide?
Yeah, do you mind going back to that slide? Sorry.
It's a big request, but it was a beautiful slide. And also, can you move, there we go. So after we identified where a person was processing quantity, we looked specifically in that region of interest for deaf signers. The green is activating during the task of subtraction.
For deaf signers.
For deaf signers. The blue is hearing non-signers, and that is also activating during subtraction. You see right and left activation, and both groups overlapped very similarly. There was no statistical significant difference in their overlap. You can see that for the hearing non-signing participants, the blue area is slightly enlarged versus the green area, but there was no statistical difference. Basically, that tells us that area in the brain is supporting subtraction regardless of language modality. Number processing for subtraction specifically.
Is it the same for language? I mean, thank you for copy signing me for everybody to see.
And we were looking only at deaf individuals who had early exposure to sign language before age 5. Not only early exposure to sign language, but they also learned math through ASL. Thank you. Oh, gosh. I thought it was a question.
All right, at this point, I just want to say thank you so much for everybody, all these amazing presenters. Thank you so much for your thoughtful questions. Thank everybody here. Thank you to all the VL2 labs for your participation. Thank you for celebrating all of the discoveries that we've made. This is my favorite event every year, and this is our 5th year of presentations. Really exciting to see all of the work that you've done to get it to this point where we are. I think there's one more slide. I also want to specifically talk about funding, highlighting NSF and NIH funds, how important and vital they are for this type of work in supporting all of the stuff we've seen. That external source of funding is so important. That funding directly connects to these discoveries, and we've benefited so much, and it directly contributes to real people. The VL community, NSF and NIH, and Gallaudet University overall. I want to say a big thank you to our wonderful community. And hopefully we'll see all of you again next year. Thank you so much. Thanks, everybody. Thank you so much for joining.